Chapter 2, Lesson 2 in Pre-Calculus, we are looking at power functions. We're going to look at monomial functions and how to graph these. And I'll spend most of this video talking about how to do it, and then I'll do another video where we'll do a number of examples. So this kind of gives you the basics or the information on what you'll need to do to graph it, and then we'll apply those by using some example. First of all, mono means mono. Mono means one. Mono doesn't mean mono. Mono a mono, I was thinking, that's why I said that. Mono means one, so we're talking about a single term polynomial. So we're talking about functions that have just one term. So you're going to have a constant or the letter x squared, x cubed, something. Just one single term is all we're looking at. And now it's important to understand now that every polynomial function is a monomial function or a sum of monomial functions, and that's important for later on as we start looking at polynomial functions that are a bunch of these monomials added together or subtracted, because then these monomials, if we know how they act, that's going to affect how they act when they're all together. So when we put these functions together, it makes it a little bit easier if we understand what an individual monomial function does. There's a little exploration on page 190 that I'd at least like you to look at, and it talks about what the graphs of x squared, x cubed, x to the fourth, and what happens as you raise the exponent. And I'll talk about that in just a second. But also one of the things I want to review is if n is even, remember, it's a reflection across the y-axis, or it's symmetrical to the y-axis. So if we know that we are looking at an even function, we know that what it looks like on the right side of the y-axis and what it looks on the left side of the axis are going to be the same. If the function is odd, remember, it's symmetric to the origin. So you can imagine taking that graph and turning it 180 degrees around the origin, and then you're going to have the same looking graph. So that's important to remember, because we're going to use all these things then to help us graph or sketch what these functions look like. And because of this symmetry then, we really only need to know what's happening in quadrant 1 or quadrant 4, and if we know that, we can then actually graph the entire function. All right. Now, what I want you to look at or see in that exercise on page 90, or that exploration, is if you have a linear function, we know that that is going to look like that, and it's going to go through this 0.11 is what it's going to do. Now, if you have an x squared, so that would be, y equals x. If you have x squared, it's going to go through that same point, but it's going to be more of a curve. If you do x cubed, it's going to flatten this out a little bit. I've got this fly flying around that's really bothering me, so if you see me waving, that's what it is. X cubed is going to be like this. X to the fourth is going to flatten out more, and it's going to still go up through this 0.11. X to the fifth is going to flatten out. So what happens when you raise the power, x to the n, the smaller this number is, the more steep it is. The higher this number is going to be more flat along here before it actually starts curving up and goes through this 0.11. They'll all go through 1 because 1 to any power is going to produce y value of 1. But the higher this exponent, the more flat this is going to be inside of this interval between 0 and 1. So the graphs of power functions, a few things that will always be on the graph. So you kind of make a list of these, and if you go through these lists, you won't have any problems at all. First of all, the 0.1k is always going to be on the graph. And remember, k is that constant that's in front of that variable that's been raised to the power a. Any positive power will also contain the point 0, 0. So along with 1k, 0, 0 will also be on the graph if the power is positive. If the power is negative, then you're going to have asymptotes, because again, a negative power, in order to make that positive, is going to move down into the denominator. That's so hard to say, really. Down into the denominator. So then you're going to create domain restrictions, which are also going to create range restrictions. So if you have a negative power, then you're going to have an asymptote at x equals 0 and y equals 0. So the graph is going to be asymptotic to both axes. And again, we'll look at that. Again, if the k value is greater than 0, because 1k is going to be on the graph, we're obviously going to be in quadrant 1. If k is less than 0, meaning it's a negative, it's going to be in quadrant 4. And then again, we talked about if it's even, it's going to be symmetric to the y, so the graph is going to be reflected over the y-axis. If it's odd, then it's going to be reflected around the origin. And finally, remember that even roots, if you have an even root, there is no graph in the negative x value. So it's undefined for values less than 0, x values less than 0, so there isn't going to be a graph on that side of the y-axis. Okay, so if we put all those together, then we can graph these power functions using a two-step process. And again, I'll show you the two-step process, talk about it, but then I will do examples in the next video. So the two-step process is this. The first thing you needed to do, why is it so hard to say two and then something after it? Anyways, what you need to do is to determine the shape of the graph in quadrant 1 or 4. Again, 1k, you're either going to graph in quadrant 1 or quadrant 4 depending upon the value of k. And you need to figure out what that shape is. And the way to figure out that shape, it goes like this. And this looks confusing, but just real quickly, let me explain it. So we talked about 1k being on every graph. So this is quadrant 1, this is quadrant 4 over here if k is negative. All right, and if a is equal to 1, meaning you have y equals x, that's a linear equation. You'll notice it goes through that point, but it's a line. Now, if that power is greater than 1, it's like an x squared, x cubed, x to the 4th. Remember, we talked about it's going to go through 1, but it's going to be curved up like this. So you're going to have this go curve up, and it is going to go through 1k. Now remember, we talked about the higher a is, the more flat this will be in here, but it will always go through 1, 1. So it's going to go through here. So every power bigger than 1 is going to have this shape. And what I like to think about is I just think about an x squared is going to go through that. If the power is between 0 and 1, remember it's a fraction, so in that case it's going to look like this blue value. So this blue line. So it's still with 0, 0, it goes through this. So anything between 0 and 1, a fractional power or a root power is going to look like this. And again, the bigger the denominator, the more flat this is going to be as it comes through here. Now we also talked about if a is less than 0, meaning a is at negative, we talked about it being asymptotic to both axes. So you'll see here we have x, and this green graph here gets close to but never touches either the y-axis or the x-axis. So this is how you would determine the shape in quadrant 1 or quadrant 4 based upon the size of the power. So again, if it's a 1, it's a line, it's a linear. If it's greater than 1, it's going to be shaped like a quadratic, and this is just going to be the higher the power, the more flat this is going to be between 0 and 1. If it's a fractional power, meaning it's a root power, it's always going to look like this. And again, depending upon the index of the root, the bigger the index, the more flat this will come out through here. And then if it's a negative value, then it's going to be asymptotic. It's going to have this shape here. Once you know that, then all we have to do is determine if the graph is odd or even, or neither. If it's even, remember, we'll just reflect that picture over the y-axis. If it's odd, we'll turn that picture around the origin. And if it's neither, then we'll just leave it as is, and that will be our graph. And again, to determine if it's odd or even, we substitute in a negative x and simplify it. If we put in negative x and get the same function, it's even. If we substitute in negative x and get the opposite function, it's odd. So that's how we will determine that. And so that's the two-step process, and within those you have these 3 steps. If you follow these, everything will be good. First of all, you're going to graph k. So you're going to use k to graph the point 1k. Then you're going to determine the shape and whether you're going to use 0, 0. Again, 0, 0 is in every graph unless it's a negative exponent. Then we determine whether it's odd, even, or neither, and then we just get the rest of the graph by reflecting it or leaving it alone. So that's the process. I will talk about and do some examples for you in the next video. So we'll end that here.